we want to solve this log equation here. We have log base 4 of 2x plus 1 equals log base 4 of x minus 3 plus log base 4 of x plus 5. Okay, so first of all, this is a log equation, right? But, just doing a quick glance here, we see that, okay, there's 3 terms, but each term has a log in it, okay? So in this case, we want to use this what's known as the one-to-one property, right? What is the one-to-one property here? It says that the log of log base b of m, if that's equal to log base b of n on the other side, okay, so if we have 2 logs on each side and the bases are the same, then, right, then we can conclude that the arguments have to equal each other, right? Well, here there's 3 logs, which is not a problem, right? We can combine these. So what we want to do is first verify that, okay, the left consists of 1 log expression and the right, okay, I can combine these here, right? So let's do that. This is a plus, so using the rules for logs, we want to multiply those guys together, right? So the log base 4 of 2x plus 1 equals log base 4 of x minus 3 times x plus 5, okay? Now, of course, this one we can simplify that, okay? So I get log base 4 of 2x plus 1 equals log base 4. And when we properly FOIL this, we get x squared plus 2x minus 15, okay? But notice here, right? Okay, I have the log on the left and the log on the right. So it turns out that these guys must be equal to each other, okay? So 2x plus 1 must equal x squared plus 2x minus 15. And this is an quadratic equation, right? We should be able to solve this guy. So let's subtract the 2x to both sides. Let's subtract the 1 to both sides. We get 0, right? 0 is equal to x squared minus 16. And this we should be able to solve, right? This is a quadratic equation. This is actually the difference of 2 squares. We get x plus 4 times x minus 4. So we get x plus 4 equals 0, or x minus 4 equals 0. That gives us 2 solutions for x, right? We get x equals negative 4 or x equals positive 4. So are these both our solutions here? Well, these are what are called, well, we don't know yet, right? Okay. How come? Right? How come we can't just say, oh, I have 2 answers, positive 4 and negative 4? Right? Remember, the idea is that the domain of the log function is 0 to infinity, right? The argument cannot equal 0 and the argument cannot equal a negative value. So we have to check these guys. Okay? These are called prospective solutions. Okay? We have to plug them in and make sure, okay, that we don't end up with a negative argument for log. Okay? Now you notice when you plug the 4 in here, right? When you plug the 4 into here, into here, into here, everything's okay, right? Okay? But what happens when you plug the negative 4 here? Okay? We get something like negative 7 here, right? Here we get negative 7. Here we get positive 1. That's fine. But if you plug the negative 4 back in here, we're going to get a negative log, okay, which we know does not work. Okay, so this is called extraneous. Remember, but have we made any mistakes here? We've made no mistakes. So that doesn't mean that we've done something wrong. It just means that when we worked out the solution, right, we got a value that did not work when we plug it in. Okay? So this is called an extraneous solution. So our only real solution here is the x equals 4.